Weighing yourself on a bathroom scale or measuring the distance between you and a friend are both very simple here on Earth. Simple compared to measuring the properties of our own galaxy, the Milky Way, as we learned in a previous lesson. But how in the world do we ascertain the properties of distant galaxies? There's no scale large enough, no ruler long enough, and no way to even get ourselves to those galaxies. At least we're within the Milky Way. The other galaxies are many light years away. There have to be workarounds for this. These workaround methods for measuring the distance to a galaxy and its mass will be the subject of this lesson. When I said that distant galaxies are light years apart, I was being very conservative. They are so far apart, astronomers have to use a special unit to measure their distance away. This unit is the megaparsec, which is equivalent to 1 million parsecs. A megaparsec is about 3.26 million light years, or 2 times 10 to the 19th miles. Anyways, the way astronomers can determine the distance to a galaxy is by looking for familiar objects called distance indicators or standard candles. These are objects such as supernovae and supergiants whose luminosity is known and are used to help find intergalactic distances. One well-known distance indicator is a Cepheid variable star, a type of pulsating variable star with a period between 1 and 60 days. A variable star is one whose brightness changes with time. This property allows astronomers to calculate the distance to its galaxy. Very distant galaxies, those beyond 30 megaparsecs, cannot rely solely on Cepheids for distance measurements. Instead, astronomers have to calibrate the distance by using nearby galaxies and their standard candles as guideposts for galaxies further out. Another way to find the distance to a galaxy is by using the Hubble Law, which is the subject of another lesson. In any case, there's one very cool thing about the most distant galaxies, those that are 3,000 megaparsecs or more away. These galaxies are so far away that you see them as they were millions of years ago, because it takes light so long to reach Earth from that distance. Once an astronomer ascertains the distance to a galaxy, either through the Hubble Law or via distance indicators, they can calculate its diameter and luminosity. For example, by measuring the apparent magnitude of a galaxy, you can then use the distance to it to find the luminosity. Such calculations have shown astronomers that galaxies are very different throughout the universe. Irregular galaxies are usually small, only 1% to 25% the size of the Milky Way galaxy, and they have low luminosity. But there are galaxies larger than our own. There are elliptical galaxies 5 times the size of our galaxy, and spiral galaxies over 4 times larger and 10 times more luminous. The mass of a galaxy is tricky to determine, just like the distance to one. An accurate way to do this is to watch the rotation of the galaxy at varying points from its center and draw something known as a rotation curve, a graph that plots orbital velocity versus the radial distance from the galaxy's center. As astronomers have measured the masses of galaxies throughout our universe, they've learned that their range of masses is quite astonishing. Some are 1 million times smaller than our own galaxy, and others are 50 times larger. This lesson went over ways by which astronomers find out the properties of distant galaxies. Distances to faraway galaxies are measured with a unit called the megaparsec, which is equivalent to 1 million parsecs. One way astronomers can determine the distance to a galaxy is by looking for familiar objects called distance indicators or standard candles. These are objects such as supernovae and supergiants whose luminosity is known and are used to help find intergalactic distances. An example of a distance indicator is a Cepheid variable star, a type of pulsating variable star with a period between 1 and 60 days. Once the distance to a galaxy is found, then its diameter and luminosity can be more easily found out as well. For example, by measuring the apparent magnitude of a galaxy, you can then use the distance to it to find out the luminosity. Finally, one method by which a galaxy's mass can be measured is by making a rotation curve, a graph that plots orbital velocity versus the radial distance from the galaxy's center.